Hello, and welcome to this live technical discussion series. So, in the last session, we talked about IES 18168 2023, which was related to ductile detailing of steel structures. And in today's session, we are going to talk about IES 16700 2023. Right. So first of all, let me thank all of you to show such a great response to this event. So still people are joining. So let's spend a couple of or few seconds wherein I'll make quick announcements and then we'll start the session. Okay, so this is the course which is coming up now, which is design of machine foundations. So we already completed one batch for this course, and now the second batch will commence from 14th December 23. So link is mentioned in the scrolling text. If you are interested, you can visit the link for more details. Okay, and right now we are live on three platforms on YouTube, LinkedIn, as well as on Facebook, so that we can reach a maximum number of engineers. Okay, so now people have started joining. So yeah, yes. Hello, Vaibhav. Hello, Vikas. So we have received very interesting points through the registration form related to IS 1670 2023. So so let's begin our session now. Still people are joining, so let's wait for a few seconds and then we'll start. Yes, welcome, Vishal. And the stream is live at YouTube also. So at YouTube, the stream will be relatively more smoother as compared to other platforms. So if you're interested, you can join the YouTube stream. Okay. And also on the YouTube, you'll be able to see that there is a join button now available. So wherein now we are offering the member exclusive videos. So by joining our YouTube channel, you'll be getting access to the videos which are only for the member and by which you can in fact support our YouTube channel. So you can refer those details by clicking on join button at YouTube channel. Yes, hello Vijay. Hello Hari Naidu. Yes, good evening all. Okay, so I think now we are good to start. Okay, so once again, thank you all for joining this interesting live discussion related to IS 16700 2023. So before we start, just let me set the context, and then we will initiate our discussion. Yeah. So you all will be able to interact with us through the live chat from any of the platform. So please feel free to write down as many points or as many uh, comments or discussion points you have. Please feel free to write down as we progress. Right. Okay. So let's start the session now. Yeah. Okay. Okay, so just let me share the screen to start with. Right. Okay, so now if we quickly analyze the registration form, like we have received very interesting points through the registration form, but if we analyze the registration form related to, let's say, the discussion point as per IS 167002023. So this is the document which we are going to discuss today. So majority of the engineers have said in summary, if I summarize all the points, of course, there were few technical points which were mentioned, but apart from that, almost 70 to 80 percentage was input related to discussion pertaining to, let's say, overview of the document and how it is going to impact, let's say, the design calculations or the design methodology what we are uh, let's say following as of today. So that was the general point really which was coming out. So so what's the point, like how we'll approach today's session now. So we'll divide today's session in the several parts. So let's say in the part one, in the initial part, we'll talk about the the latest changes which are made in the document. In the part two of today's discussion, then I'll highlight few few important points related to software application, because that's very important part. Of course, we will not be able to discuss each and every point, like how it can be applied in the software. So that part we will discuss separately, but at least I'll try to highlight a few important points which are to be taken care with reference to the software applications. And then today in the part three of discussion, we will talk about let's say remaining part of the document which is important. Okay. And of course, then finally, let's say we can say part four, wherein we will have the open discussion, wherein we'll take up the discussion points, queries, whatever you have shared through the registration form, as well as, let's say, the points which are we are receiving through the live chat. So as we will be progressing, let's say today, let's say part one, part two, part three, part four, but you need not follow this sequence. You can start mentioning the points related to any part of the discussion. So that will be also helpful for arranging the talk in the, let's say, for the future sessions. So we will collate all the input, and that will be useful for conducting the future sessions related to this important document. Okay. So today, our main focus will be to talk about the overview of this entire document, and let's follow this sequence so that we can cover majority of the part related to the document as we have received the request from the registration form. Right. Okay. 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 So let me share the document now. Yes. Okay, so firstly, let's talk about the revisions or the changes which are made in the document. So this is highlighted here in this part of the document. So let's quickly go through this part, which you all must have seen, but let's go through quickly, and then we will try to locate this different part in the document. So this is one of the major change in which now system with only core walls, structural core walls is dropped. So that means now structural wall system uh, shall be, or let's say should have been, well distributed walls only. There is no option of now only core structural walls as it was there or it was available in the earlier part of the document. Okay, just let me fix it on this white. Yeah, just let me fix it correct. So as we were discussing that core part of structural walls, so only exclusively core walls are now not allowed. Okay, so that is one of the change. And let's look at other parts of the change. Second part is the wind return period of wind for the natural drift under wind conditions has been now revised. That's the second change. Uh, Third change, requirements for maximum vertical acceleration of floors have been dropped now. So the requirements which were there in the earlier part of the document is now dropped. Maximum horizontal acceleration requirement has been revised for the residential buildings. Now, this part E is one of the major change we can say, which is a new expression for estimating the approximate fundamental natural period of buildings over 50 meter has been provided. And we'll see this equation where now there is no relation with reference to, let's say, the base dimensions. Load combinations has been specified for considering P delta effects. So so this is one of the part related to software application, right? So now it is specified the load combinations for the P delta effects as well. An expression for interstory drift stability coefficient is now has been introduced now. So the formula has been revised. The minimum requirement for the transverse reinforcement in the structural walls has been revised, as well as the procedure for approval of buildings which do not conform to the prescriptive requirements of this standard has been revised in the annexure B. So as we all know that this standard is stipulating the prescriptive requirements. So if we are not meeting specific prescriptive requirements of this document, then in that case we need to follow the procedure which is shown in the annexure B of this document. So that procedure has been also revised in this revision of the document. So let's quickly locate few parts of the document where changes have been made. So this first part, like if we see this table, we could see that earlier the option was for the core structural wall, as well as there was a second option for the structural wall, which is well distributed. So now the core structural wall option is removed, and that is not allowed now. And also it is mentioned here, the structural walls are considered to be well distributed when structural walls that are outside of the core are capable of carrying at least 25 percentage of the lateral loads, right? So that requirement is specified. For the lateral drift, the maximum interstory lateral drift ratio under serviceability loads, including wind load with the return period of now 20 years. So, and that is estimated based on again sectional properties, which is stiffness modifiers, which are specified in the 7.2. So that shall be 1 divided by 500. Okay, so I'm trying to locate the changes as I have studied this document. So please feel free to populate the chat, whatever additional things you have observed in this document. There's also one more change, like we are considering diaphragm action for the earthquake resistant design. So now this requirement is specified, like at any story, the minimum width of floor slab along any section after deduction of the opening shall not be less than 5 meters. And this requirement or this clause is applicable when we do not have the perimeter beam. So if we do not have the perimeter beam, so in that case, the minimum width of the floor slab along any section after deduction of the opening shall not be less than 5 meter. Now 5.7.2.3, it is related to lapping of the longitudinal bars. And as it is indicated in this clause that now rebar couplers or mechanical couplers are mandatory. So as it is mentioned here that when diameter of bars is 20 mm or higher, mechanical couplers as per IS 16172 shall be used to extend the bars. So whenever bar diameter is greater than 20 mm or even let's say if it's 20 mm or higher, so in that case mechanical club couplers are mandatory. So I think this is also one of the major change. Then related to lateral acceleration, like from serviceability considerations under standard wind loads with return period of 10 years, the maximum structural peak combined horizontal acceleration in the building for along and across wind directions at any floor level shall not exceed the values which are given in the table 3. So table 3 identifies the maximum values of allowable, or let's say maximum peak combined acceleration which is allowed. In para number 6.3.2, it is said that for buildings in seismic zone 5, deterministic site specific design spectra may preferably be estimated and used in design. So it is said that it may be used. because of certain practical difficulties. Now it is mentioned that it may be used, so it is recommended that we use deterministic site specific design spectra whenever buildings are located in seismic zone 5. But the statement is I think updated, and with the it is mentioned as may preferably be considered or be estimated. Para number 6.3.4 is one of the major change we can say. So it's related to fundamental natural time period. And as we were talking in a number of sessions, and I was also sharing my point of view that our all formulas related to time period in different Indian Standard Code needs to be revisited. Uh, so here also now we could see that the changes are proposed. So for the buildings which are greater than 50 meter, the formula which are recommended here, we could see here that now it doesn't have any dependency on the base dimensions. So this is one of the major change which is made in this document. Yeah, and regarding a p delta analysis, as we just discussed in the initial part of this session, that there is always a confusion related to p delta analysis. What are the load combinations to be considered? How it is to be considered in the software? Now, again, it's a different point of a discussion which we'll discuss in detail in a separate session. But now this is the change which is made in the document, wherein the load combinations are now identified for the p delta analysis. So which is nothing but 1.2 times dead load, zero point 0.5 live load, and 1.5 times either seismic load or the wind load. Okay, in para number 7.3.10, the flexibility of the building shall be such that the inter-story drift stability coefficient, which is denoted as a theta, shall satisfy the following condition. So the equation is given, and whatever value we derive out of this, that shall be less than or equal to 0.2. So this is also one of the change. Okay. So I think here one change is made related to topmost slab between the towers of connected podium shall be at least 150 thick with double mesh reinforcements, not less than 0.25 percentage cross sectional area in each direction. Then in para number 8.5.1 sorry 8.5.13, so it's talking about reinforcement requirement for the structural wall. So for the minimum longitudinal reinforcement in the structural wall, it shall not be less than 0.4 percentage of the gross cross-sectional area. And the minimum transverse reinforcement in the structural walls shall not be less than 0.25 percentage of the gross cross-sectional area. Now we know that the flat slab structures doesn't perform well during seismic events. So of course, it's written very clearly here that wherever structure is having flat slab system, as let's say gravity load carrying system, so structural wall shall carry all lateral loads on the building, and the column strips of the flat slab system shall not be included in the lateral load resisting system. But what is the change made in this paragraph in 8.6.1? Now it is said that all requirements related to the structures with the flat slabs, which is mentioned in IS 1893 Part 1, shall be met with. So the requirement related to drift, punching shear, etc., whatever is mentioned in IS 1893 Part 1 shall be considered while designing the structures using flat slabs. So here reference is given to 1893 Part 1. Yeah, and the final change is in the annexure B. So wherever building or let's say the tall building is not meeting the requirements of this document, or let's say the prescriptive requirements of this document. So in that case, earlier it was considered as a code exceeding buildings or code exceeding structures. But now that nomenclature is changed in this annexure, and now it is said that it's not conforming to the prescriptive requirements of this standard. So when the building is not meeting, let's say, the prescriptive requirements of this standard, then the procedure which is outlined in the annexure B, that has to be followed. So now there are changes. Of course, one of the paragraph related to performance-based design is now removed, as I could see, for more clarity. And it gives the overall or general process whenever building is not meeting the prescriptive requirements. So one more change we could see here, that two nomenclature are given. One is the STR, which is a structural design review panel, STR, and the building authority having jurisdiction, BAHJ. So, so everywhere these short forms are mentioned in the document, right? Okay, so this is what I could gather as a quick as a changes which are made in this revised document, right? So now let's move to the second part of our discussion, and wherein uh, let me highlight quickly the important points related to software applications of while performing the design of tall buildings with reference to this document. Now, as we discussed in the initial part of the session, that we'll just highlight the few of the important points which I have gathered while studying this document. Still, we are studying this document, and we will uh, refine our list of those points. But right now, we'll just highlight the points which needs to be considered from the software application point of view, right? Now it's said that the aerodynamic effects. So when elevation, profile, facade, features of the building, and let's say plan shape of the building, shall be such as to attract minimum wind direct effect. Now, effects of the features, such as let's say if we have the sharp corners or let's say the projected balconies, then that shall be considered in the design. Okay, how it is to be considered, that we'll discuss separately. For the story stiffness and the strength, it is mentioned that lateral stiffness of any story shall not be less than 70 percentage of that of the story above, as well as lateral strength of any story shall not be less than 90 percentage that of the story above. So we'll require this input from the software, right? So that we meet requirements of this paragraph. Lateral drift, of course, which is identified for the wind as 1 divided by 500. And let's say for the seismic, or let's say for the earthquake force, it is HI by 250. And that we need to calculate, that drift needs to be calculated considering the property modifiers or stiffness modifiers. So that's the software application will come in point. Natural modes of vibration. So as it is mentioned in paragraph 5.5.1, the natural period of fundamental torsional mode of vibration shall not exceed zero point 0.9 times the smaller of the natural periods of the fundamental translational modes of vibration in each of the orthogonal directions in plan. So in short, the torsional mode shape shall not be first mode shape, and there shall be the sufficient gap between the mode shapes. So that's what is identified with reference to, let's say, this 0.9 times. So software application will come in picture for this point. And the fundamental translational natural period of any two horizontal plan directions shall not exceed, of course, 8 seconds. So upper limit is specified 8 seconds, considering the, of course, sectional properties as per table 5, corresponding to serviceability requirements. When there are openings in the floor diaphragm, so of course, firstly, openings in the floor diaphragm shall not be permitted along any floor diaphragm edge specifically, unless the perimeter members are shown to have stability and adequate strength. So that needs to be determined through software application, like that the perimeter beams or perimeter members have adequate stability and strength whenever we have the opening in the diaphragm at the edge of the floor. Then para number 5.8 is related to progressive collapse. So what is said here, that the possibilities of progressive collapse shall be precluded by selecting structural systems that are appropriate for ensuring structural integrity, adopting rigorous structural investigations that verify acceptable structural behavior, even when select critical members do not play their intended role, and providing adequate redundancy and integrity to the structure. So here also the software applications will come in picture. And the key elements are identified, like these are the members which is defined in the earlier part of the document. And here it is said that whenever we have the key elements, so key elements are the members, joints, or other components whose failure would result in a disproportionate deterioration of the building and whose presence is vital to ensure ductile behavior of the building. So vertical and lateral resistance of key elements shall be improved in many ways, including, let's say, by the use of higher partial safety factors for loads and materials to ensure that they do not yield before the designated ductile elements. Right, so here software application will come in picture, and the elements which are adjoining key elements and capable of providing an alternative load transfer path. Of course, so those members or elements shall be suitably designed and detailed, because in case of extreme seismic events, the forces will be could be transferred through the adjoining elements. When the failure of key elements is triggered, let's say in the extreme events, right? So adjoining elements should be suitably designed and detailed. When wind tunnel studies indicate that torsional motion or structural system of the building should be modified suitably. So what it says that whenever wind tunnel study is carried out, and if it is indicating torsional motion, so in that case, the structural system of the building should be modified suitably to mitigate the torsional effect, so as to bring the torsional velocity below 0.003 radians per second for 10-year return period. The damping ratio is limited to 2% of the critical damping for the concrete buildings, or we can say for the tall concrete buildings, which is having height greater than 50 meters. Lateral acceleration we just discussed in the initial part of the session. So these maximum allowable values we need to check with reference to, let's say, software calculations. For the seismic effects specifically, vertical shaking shall be considered simultaneously with the horizontal shaking for tall buildings in seismic zone 5. So when building is located in seismic zone 5, we need to consider vertical shaking also in combination with the horizontal shaking. The computer modeling shall consider the following, like rigid and offset of linear members in the joint region when centerline modeling is adopted. First point. Floor diaphragm flexibility as applicable. Correct cross-sectional area properties as per table 6. And the load combination, which we just discussed for the P delta effects. So that is mentioned now. Para number 7.3 is related to modeling. So many points will be applicable with reference to the software application, we can say. So in para number 7.3.3, it says that in plane stiffness of the floor slab shall be modeled unless it is demonstrated that it is extremely stiff and sufficiently strong to remain elastic under seismic actions. Right. Then it says that in moment frame buildings, when buildings with unreinforced masonry infill panels contribute to story lateral stiffness, so then in that case we need to consider the stiffness which is provided by masonry infill in form of equivalent diagonal struts as it is defined in IS 1893 part 1. Correct sectional properties shall be used. So those are defined for strength criteria as well as for the serviceability criteria. Right? Then in para 7.3.7, in reinforced concrete buildings, lateral deflections which are resulting from unfactored lateral loads, so that shall be estimated using section properties intended for use with the unfactored lateral loads. And similarly, if lateral deflections resulting from the factored lateral loads, so in that case, we will use the section properties which are intended for use with the factored lateral loads. So now this is further clarified how to consider the stiffness modifier or when to consider which type of stiffness modifier. Buildings may be considered to be fixed at their basis for determining the lateral effects on the buildings. And when we are modeling the flexibility of the foundations, so in that case, the references shall be made to para number 8 and 9. And now, as it is mentioned in the next paragraph, like when the foundation flexibility is included in the linear analysis, the load deformation characteristics of foundation soil system shall be accounted for by equivalent linear stiffness using soil properties that are consistent with the soil strain levels associated with the design forces. And one more important point which is made in this paragraph, a 50% increase and decrease in stiffness. So whatever stiffness we derive out of the method which is just mentioned above, we need to increase that stiffness by 50 percentage and we need to decrease the stiffness by 50 percentage, and that shall be incorporated in the dynamic analysis unless smaller variation can be justified. And of course, the whatever largest value of the response, whatever we get out of this exercise, that should be considered for the raft design. So here we can say that significant, or instead of we can say that, let's say effective interface is required with geotechnical consultant. And whatever stiffness values we determine out of this exercise, so that shall be increased and decreased by 50 percentage. And of course, whatever or whichever value gives the maximum response, that shall be considered for the further design. Right? So it's mandatory to use P delta effects. The flexibility coefficient, as we discussed, so this value needs to be checked from the output of the software. Then para number 7.3.11, the stiffness of frames with flat slabs as horizontal members shall be ignored in lateral load resistance, as we just discussed, right, in the different paragraph, but the same thing was mentioned. So in all seismic zone, the lateral stiffness or lateral load resistance shall be ignored by slab column frames, and this shall be designed as gravity elements for the deformation compatibility. So for the deformation compatibility, so there are clauses included in 1893 part 1 as well as in 13920. So same clauses may be referred for the deformation compatibility. 7.3.12, the model which is used in structural analysis of solid coupled, perforated, or let's say the punched structural walls shall represent stiffness, strength, and deformation capacities of structural wall. Structural wall segments and coupling beams or spandrel connections between structural walls. Right. The stiffness of coupling beams and spandrel connections shall be captured aspect ratio of this coupling beam and spandrel connections and extent of cracking anticipated and reinforcement provided in them. So this we need to take care. In 7.3.13, it says that the construction sequence shall be considered whenever building height is greater than 150 meter. Right. Then the towers which are connected by a podium shall be modeled separately as well as integrally. 7.4 paragraph is talking about building moments. So for buildings which are taller than 150 meter and for buildings taller than 100 meter with mass asymmetry, analysis shall be carried out for both vertical and horizontal long-term building moments. So which is very essential for the tall buildings. So that analysis needs to be carried out using software, right? Then the measures shall be taken in concrete and composite buildings to minimize the adverse effects of shrinkage, creep, temperature variation, and the foundation settlement during the design life of the building, not less than 30 years. 7.4.2 is talking about non-structural elements such as, let's say, curtain walls, claddings, partitions, finishes, etc., and let's say service installations. For example, elevators, vertical pipes shall be required to withstand long-term movements of the buildings and associated differential effects. So here it says that appropriate vertical compensation and sway compensation shall be accounted for during the construction. So once we calculate the building moment for considering, let's say, long term condition, so then the compensation shall be made accordingly for the vertical as well as the horizontal moment, or let's say the sway compensation during construction. In gravity load analysis, internal forces shall be considered which are developed due to differential vertical moment of the vertical structural elements due to shrinkage, creep temperature, foundation settlement, and construction compensation. And in any case, the total shrinkage strain of concrete shall not exceed 0.04 percentage. And to calculate the effect of creep and shrinkage, the selected strain prediction models of concrete shall be based on established principles of mechanics elaborated in specialist literature. Because whatever building moments which we calculate, which is a long-term building moment, so creep and shrinkage, whatever we calculate, so that shall be from the established or elaborated specialist literature. Otherwise, the whole calculation will go wrong. For staircases, if it's a built integrally with the structural system of the building, And if it is not confined by the structural walls, so that shall be included in the three-dimensional structural model, and its elements designed as per forces induced in them under various load combinations. Alternatively, a sliding joint may be provided. Okay. Para number 8.1.3.2, and out of that 8.1.3.2.1, sorry, 8.1.3.2.1 is talking about sensitivity analysis. So as a part of collapse prevention evaluation, two sets of backstay sensitivity analysis shall be carried out using upper bound as well as let's say the lower bound cracked section properties of floor diaphragms, and the stiffness parameters for those diaphragms and perimeter walls of podium and below the level of the backstay are given in the table number 6. So these are the parameter, or let's say values, which are given for the upper bound as well as for the lower bound values. So here software application will come in picture. Besides that of the floor diaphragms, the flexibility of following structural elements in the structural analysis with appropriate modification to their stiffness, perimeter walls and their foundation supports, first thing, and secondly, foundation supports under the tower lateral load resisting system. Right. Then there is a back stay analysis. So in the back stay analysis, as we know, we need to consider two different load path. So one is we can say a direct load path, and the second will be backstay load path. And the response or the response quantities to be calculated for these two different conditions. Backstay floor diaphragm shall be modeled considering their in plane and out of plane floor flexibility. And if there is any large discontinuity present in the slab, shall be modeled. In the direct load path case, the vertical stiffness shall be considered of the piles, foundation, and the supporting soil. And in the backstay load path case, the relative stiffness shall be considered of the floor diaphragms and perimeter walls along with the vertical in-plane rocking stiffness of soil below the walls. And also horizontal pressure imposed by soil on the retaining wall shall be considered. And at this point of time, or in this condition, the axial stiffness of elements along load path shall be reduced to account for cracking, bond slip, interface slip, and other such effects. Okay, so and the backstay diaphragm shall be designed in accordance with the following. They shall be designed for the maximum of the forces derived from the sensitivity analysis, as we just discussed. And when the lateral force resisting system of a, let's say, tall building, which is if it's having a plan irregularity as per table number 5 of IS 1893 part 1 of, let's say, type 1 torsion irregularity, type 2 is the re-entrant corners, type 4 out of plane offsets, and vertical irregularity as per table 6 of IS 1893 part 1 of Type 4, which is in plane discontinuity of vertical elements resisting lateral forces. So in this case, the seismic forces shall be amplified by a factor of 1.5 in the design. Similarly, if when the lateral force resisting system of a tall building has plan irregularity of type 3, which is diaphragm discontinuity, as per table 5 of IS 1893 part 1, at the bake stay diaphragm levels, collector elements and their connections to the vertical elements shall be designed to resist seismic forces which are amplified by an overstrength factor of 2.5. Now 8.1.3.3.2 for the structural walls. So structural walls or shear wall, let's say, can sustain the plastic hinges at the level of the backstay diaphragm also. So such walls shall also be designed and detailed for the plastic hinge development at that level. When towers are connected by a common podium, so in that case, the such buildings shall be modeled as separate towers as well as the integral tower as we just discussed, and the podium shall be designed based on the worst of the two results. And for estimation of the natural period for calculation of base shear, it shall be based on the individual building model. So all those points, whatever we are discussing, those are related to software applications. The directional effects for all worst possibilities, that is, let's say tower shaking in the same direction, or let's say if it's shaking in the opposite direction, so that should be considered in the design load combinations. And equivalent static seismic forces we can use, provided if we are scaling those forces to match to have same value of base or turning moment which we obtain from the response spectrum analysis. And where the significant changes occur to the mass or stiffness, so in that case the diagram forces equivalent beam approach, finite element approach or strut and tie approach may be adopted to model the diaphragms. The potential cracking in the diaphragm by considering an upper bound or a lower bound axial stiffness, as we just discussed, and the lower and the upper bound values of axial and flexural stiffness as it is given in table 6 for the sensitivity analysis may be considered for the cracked section properties to arrive at the design level earthquake demand on the RC diaphragms. Now here it says that certain type of irregularity, let's say torsional irregularity, diaphragm discontinuity, shall not be present in the first topmost connected floor and the first floor of the tower above the connected floor. And similarly, vertical irregularities of type 1 as per table 6 of IS 1893 shall not be present in the first connected level and the level above it. The topmost slab between towers of connected podium. So this we discussed, right, as a change. The frame structural wall system shall be designed as a dual system. So for the dual system, the paragraph or requirement is mentioned in IS 1893 Part 1. So same requirement needs to be considered. And the gravity column in the structural wall buildings shall be designed as per requirements of deformation compatibility on known seismic members. So basically, those shall be designed as a gravity column as it is defined in IS 1893 Part 1. So this is also one of the important point for the software application, you can say. The design of coupling beams shall comply with the requirements of IS 13920 unless it can be shown that loss of stiffness and strength of the coupling beam will not impair the vertical load carrying ability of the structure. The requirement for each story resisting more than 35 percentage of the design base shear. So here it is said in para number 8.5.12 that structural wall with a height to length ratio greater than 1 may be removed in any story above if it accounts for the less than one third of the story shear strength. And further, the resulting structural system must not have any torsional irregularity. So that's the important part, which is mentioned in the last part of this paragraph. Flat slab, we have discussed this part. For modeling of the soil also, we touched upon a couple of areas. For the factor of safety of 1.5 shall be provided against overturning and sliding under, let's say, unfactored design wind load and gravity load and other permanent imposed loads. It is 2.5 times design earthquake load, unfactored gravity load, and other permanent imposed loads. So these are the factor of safety for the foundations. Then, yeah, modeling of the soil. So of course, as we discussed that for this, we require effective interface with the geotechnical consultants. So while modeling the route foundation through spring constant or modulus of subgrade reaction, so this is what we should look for, which is zoned spring constant or zoned modulus of subgrade reaction. So what does it mean? That the value of spring will not remain constant across the length of the raft. And that shall be utilized for the design, at least for the case of dead load plus live load condition. And for design of rafts for building taller than 150-meter, a soil structure interaction study is shall be conducted using actual column loads and column locations to obtain the zoned spring constants. And for piled raft foundations, the designed with the settlement reducing piles. The soil structure interaction study shall be conducted with actual column loads and column locations, and this analysis shall be conducted at a minimum of following loads. Okay. The settlement of foundations are mentioned like maximum vertical settlement of raft or piled raft foundations under gravity loads shall comply with the requirements of specified standards, and the maximum vertical settlement is limited to 125 mm in the raft or raft pile foundation, subject to maximum angular distortion of the raft not exceeding 1 divided by 500 and 50 mm in rock. Okay, this paragraph or this section is related to requirements for the non-structural elements of this. We will discuss in one of the separate session itself. But there are now requirements specified for the non-structural elements. So it is said these are the recommendations. So for these also, the specific or we can say detailed calculations are required. Okay, so these are few of the important points related to software applications. So that was coming out as one of the point in the registration form, like what are the different points to be taken care related to software applications, right? So I've just tried to summarize the areas which are important for the software application. And now, just for now, in let's come to the next part of our discussion, wherein let's touch upon a few of the remaining important part of this document. So always scope of any document is very important, scope as well as forward. So as we all know that this document will be applicable for the buildings which are, let's say, height lesser than what 250 meters, between we can say 50 meter to 250 meters. That's the range in which we'll consider this document. And this entire document is specifying prescriptive approach. Now, this standard shall not be applicable for tall buildings if those are located in the near field zone. Now, the definition for the near field zone, for specifically for this standard, it is considered as 10 kilometer shortest distance from, let's say, seismogenic fault. So for those building, of course, we need to consider the requirements which are mentioned in this part of this document. But additionally, special requirements needs to be considered, which is beyond scope of this document. And that's why whenever building is in such a zone, additional precautions shall be taken. And this applicable for buildings that house 20,000 or fewer persons. If number is higher than 20,000, this is not applicable. Or prescriptive requirements of these standards is not applicable, we can say. And this is very important, as we discussed during the session, that whenever buildings do not conform to the prescriptive requirements of this standard, then more rigorous procedure is necessary for the design and review. So the general procedure is outlined in Annexure B for such kind of buildings. For the connecting structure, so there are two distinctive types of connecting structures, with one requiring a different structural treatment, namely. So first is, let's say, the connecting structures having the role of transferring only gravity loads with no participation in resisting the lateral loads. And the second case will be where the connecting structure participating in the lateral load resisting structural system. Right? So in both the cases, of course, the treatment what we give to the structure will be different. The definition of key element is defined in paragraph 3.7. As we were talking, the requirements of key elements. So here, definition is given for the key elements. And in this part of the document, in the paragraph 3.12.5 onwards, it is identifying the different structural systems for the tall buildings. Let's talk about transfer structure a little bit. So transfer structure, like a structure which is comprising of horizontal deep beam, trusses or thick slab, so which will transfer the load action and support the vertical elements. Above two vertical elements, below that are not aligned. So when vertical elements are not aligned to each other at a particular level, so in that case, those elements will be supported by very deep horizontal beam. So that's the transfer structure, right? Let's go. The plan aspect ratio is identified like maximum plan aspect ratio of the overall building shall not exceed 5. In case of L-shaped building, LT and BT shall refer to the respective length and width of each leg of the building. Yeah. The natural vertical vibration frequency of any floor system shall not be less than 3 hertz. So when we'll perform dynamic analysis, we will get the frequency of the structure, or not of the structure, but of the particular floor in the vertical direction. And that frequency shall not be less than 3 hertz. For the wind effects, it is said that for buildings with height greater than 150 meter, so in this paragraph, it is identifying in the para 6.2.1, it is identifying requirements of wind tunnel testing. So when, let's say, the height greater than 150 meter, or with complexities in the plan or elevation geometry, or sited on complex topography with the group effect of or interference effect, or let's say because of the adjoining structures or buildings, let's say there is a possibility of interference effect. Now that interference effect may be existing or maybe future potential. Let's say the tall buildings are, or let's say other facilities are likely to be constructed, or whose natural period is greater than 5 seconds. So in all these different conditions, if any of the condition is, let's say, meeting, or let's say is applicable, then wind effects shall be determined by site specific wind tunnel studies. So there may be two cases when we go for the wind tunnel studies. The wind tunnel studies may be higher or the lower with reference to the, say, the wind force calculations what we do as per IS 875 part 3. So for both the cases, the the methodology is given here. So whenever the wind tunnel studies are lower than the, let's say, shear and moments as per IS 875 part 3. So in that case, the minimum design wind based shear shall be at least 70 percentage of that derived based on IS 875 part 3. Okay, so the minimum design based shear coefficient is defined in table number 4. As said in para number 7.4.3, the details of components or connections of non-structural elements with the structural elements of the building shall be planned such that their relative moments are allowed without causing distress to both structural and non-structural elements. This we have seen already. For the backstay effect, we will have a separate session because there are also few points I could see from the registration form. But we'll discuss these in detail along with the software application. So, so I'm highlighting few of the remaining points or important part of the document after, let's say, covering major changes as well as software application points. One of the point is frame structure for seismic design shall have at least two planar frames with minimum three bays in the direction where the lateral load resistance is provided by the moment frames. The thickness of the structural walls shall not be less than 160 mm or HI by 20, whichever is greater. But of course, we need to relook on to this thickness according to me from the constructability aspect. So 160 mm is always it's a minimum value. In this paragraph 8.5.2, the how the openings in the structural walls are to be considered or to be taken care. So that is mentioned here. And beams carrying a predominant vertical load shall not be supported on the coupling beams. Okay, here it is identifying the limit for nominal design shear stress, which shall be limited to 0.5 tau c max in the structural walls under tension in any load combination, and coupling beams in structural walls under factored design loads. And wherever yielding is possible or likely to occur, we need to consider the reinforcement or longitudinal reinforcement development length shall be 1.20 times 25 times the values which is calculated for the bar yielded in tension. Okay, in para number 8.7, it's talking about framed tube system, tubing tube system, and multiple tube systems. So those requirements can be referred here. Modeling of soil, we have seen depth of foundations. Okay, for depth of foundation, there's a paragraph like the embedded depth of the building shall be at least 1 by 15 of the height of the building for raft foundation and 1 by 20 of the height of the building for pile and piled raft foundation. And when the foundation is resting on the hard rock, or let's say when there is no uplift under any portion of the raft in any service load combination, and provided the minimum component or minimum competent founding strata rather, the requirement is fulfilled. So only in that case these requirements can be relaxed if we are meeting these two requirements. Otherwise, the depth of the foundation should be considered as it is mentioned here. The podium and basement roof slab shall be capable of transferring in-plane shear from tower to the foundation. And para 10 is talking about recommendations for the non-structural elements. And para number 11 is actually talking about monitoring deformations in the building. So that's very important according to me. Like uh, the monitoring is extremely important, that how whatever, let's say, design we have performed building is executed, and let's say the earthquake strikes, or let's say earthquake occurs at that particular site where building is located, or let's say there is a wind velocity which is increased. So in that case, if we have the instruments placed in the building, so then we can record the the movement of the building, and with those kind of database, definitely we can further improve our codal provisions, right? So I think this is very important part. So it's talking about measurement for the earthquake shaking, then for the wind oscillations, and also for the foundation and settlement pressure measurement. So whatever we have considered during design stage with let's say effective interface with the geotechnical consultant, and whatever long term deformation, or let's say long term settlement, whatever we have conceived. So now what is the actual settlement which is happening, let's say on year to year basis? So that can be monitored, and that will give more confidence and more data to us for refining our industrial practices. And the annexure B, as we just talked, that this will be applicable when building is not meeting the prescriptive requirements of the standard. So it gives a broad outline like how the step-by-step approach should be followed. Now, in the entire process, it is an only generic format which is given here. So this checklist, when we look at here, so it's only generic checklist. It is not comprehensive, rather, like as it is in fact mentioned here also that this checklist is generic. So accordingly, the detailed checklist should be prepared for the structure under consideration, and based on that, whether code is complied or not, that should be mentioned. So it is written in a fairly detailed manner, of course. So this is the last part of this document, which is the annexure B. Okay. So with this, I have just tried to summarize the overview of this very important document for design of the RCC tall buildings, right? And this is what we received as an input through the registration form, right? So I'll just write uh, okay, so I just try to share my point of view and my understanding with reference to this standard. So if you have a different understanding, different perspective, or let's say different viewpoint, please feel free to share in the comment box. Okay, there are few pointers we could see here. That earlier version of the code used unfactored load in table 5, but the amended version is using serviceability loads since unfactored criteria. Yeah, created a lot of confusion. Yeah, you're right, Aditya. In the earlier version, it was factored versus unfactored, and now it is improved with the serviceability and strength criteria. So now it is more refined version, we can say. And I believe that now all confusion is removed. Abhishek is saying that, sir, please highlight that what's the difference between the lateral stiffness and lateral strength, and how to check it in the software. So that's what we'll see in the separate session, like how specifically we can check all the different points in the software. But your point is right. This is precise point where we should focus. That once we understand the intent of particular clause of the document, now how to check in the software. Okay, Hari Naidu is saying that it is clearly given in IS 1893 Part 1, Table 1, that we can increase the soil bearing capacity by 50% for seismic load combination. Can we increase SBC for the wind load combinations? Yeah. Okay, so your question is that can we increase the SBC for the wind load combination, right? So I do not have very clear answer to this, and I've always seen the difference of opinion happening. Of course, when I was designing the industrial structures in oil and gas industry, so at that time also the difference of opinion was there. But let's park this point, and I'll come back to this. You can connect with me separately, or I would request that you please put this as a comment on the YouTube video, and then respond to this according to my understanding. Okay, so at least I've tried in the first session of IS 16700 2023 to give the quick overview of the document. All right, so please feel free to put additional point through the chat box. Okay, Harinaidu, what's the criteria for high-rise building? Okay, so high-rise building, see, as it is said that when building height is increasing beyond 50 meters, we can say it's a high-rise building, or where IS 16700 will be applicable, right? Okay, Salman is saying on what guidelines new time period as 16700 2023 should be adopted. So there are no guidelines now, whatever equations are given in the latest document. So that should be considered. Okay, Moshin is telling why is that they removed core wall system from the code? Was the results obtained not safe? Will it make previously designed structures obsolete? Okay, good question. So as I understand, like when we provide only core structural wall as a lateral load resisting system, see that means we are concentrating our stiffness at a center part of the structure, right? So during the seismic event, or let's say when we refer to the dynamic behavior of the structure, there is a quite possibility that we will get torsional mode shape. So that was one of the reason, as I could think, I could see that core structural walls are removed, and then it is suggested that we must go for well distributed walls. And when we say well distributed walls, that means the walls which are placed on the outer periphery of the building. Okay, so okay, Hiren by saying that any reference or research behind new time period formula. Okay, so as I could understand that during formulation of this standard, different country code might have been followed. Uh, and in the different country code, if we see that, then the time period is not dependent on the base dimension. And specifically, it is, let's say, height of the building, which is greater than 50 meter. So right now it is taken from the different country code or different international codes, as I understand. But as we were just discussing in the last part of the document, which was paragraph number 11, where instrumentations shall be placed, and by placing instruments into, let's say, more and more tall buildings across the country, we'll be having more data with us, and with this we can further refine our time period formula. So we can say right now, as I understand, this time period formula is not derived based on the indigenous, or let's say based on the database of our tall buildings, as I understand. Yes, yes, welcome, Mosi. Okay, yes, most welcome, Hiran bhai. Okay, so I hope you we would have got at least overview of this document, and that's what was requested during the registration form. So we'll be coming up with the different part of this series as we proceed. Right. So with this now we are going to close this session within few seconds. So if you have additional points, or let's say if you want to share anything else, please feel free to share. And once we close this stream, it will be uploaded automatically on the YouTube, LinkedIn, as well as on the Facebook. So please write down other discussion points, other queries, comments also, so that will help us for creating let's say discussions for the other sessions. And as we have discussed that the software applications is approximate or extremely important rather when we refer to this document, right? Okay. So with this, let us stop at this point, and we'll meet soon again again with the very interesting technical discussion. Okay. So we are closing this session now. Good night.